Hello everyone. In this video, we would be working out few more problems based on substitution method. So let's start with the problem. Here we have integral x divided by root of x plus 4 and x is greater than 0. Why do we specify that x is greater than 0? There's a reason behind it. Whenever we have a denominator with a root, we always specify x has to be not only denominator, generally when we have root we specify x has to be greater than 0 because if x is becoming less than 0, for example, I have minus 5 plus 4, I would be getting root of minus 1. The root of minus 1 comes under a complex number. Just to avoid the complex number, we give the condition very clearly that the result, whatever you're going to get, is a real one, not a complex one. So just to avoid the complex number concept. So that's the reason they are being clear with what the function is, how the function has been defined. That's the reason. Now let's start with the problem. I would be considering this as I is equal to. Since I'm using substitution method, obviously the one when I just go ahead and substitute, I have to get the other part of the question. So which I'm considering. But here, let me consider, let x plus 4 be equal to t. If x plus 4 is equal to t, so when I differentiate, I would be getting 1 is equal to dt by dx. So this implies that dx is equal to dt. Now in my problem, what has happened is I have only dx and it is getting replaced by dt, but I have x here. What I would be doing with the x. So x is nothing but t minus 4. Now let me just go ahead and substitute and change everything in x to t. So x becomes t minus 4 and then dt divided by root t. So almost the substitution work has been done. Now let's just split it. So when I split this, I would be getting, see here I would be having root t minus 4 by root t dt. What exactly has happened is, the rough work I'm showing in a different color. See, I have t, which is nothing but root t into root t. And then divided by root t, I have t by root t. Okay. So one of the root t is getting cancelled, then only I'm getting it as root t here. So that's how it is formed. Now let's go ahead and integrate it directly. T to the power half, when I integrate, I would be getting t to the power 3 by 2, t to the power 3 by 2 divided by 3 by 2 minus 4 into, I would be getting t to the power minus half. When I integrate, I would be getting t to the power minus half plus 1, which is t to the power half divided by half. Then plus c. The denominator's denominator will become a numerator, and I would be having 2 by 3 into 3 t to the power 3 by 2 minus 8 t to the power half plus c. What exactly is my t? Let's go ahead and substitute that. So now here the t is 2 by 3. T is nothing but x plus 4 whole to the power 3 by 2 minus 8 into x plus 4 whole to the power half plus c. Further, if you like to simplify, in that case, what we can do, we have few common things. So let's do that as well. So now here x plus 4 whole to the power 1 by 2 is a common. And then, so if I take that out, so here if I take 1 by 2, then what would be remaining here is x plus 4. Okay, so now here, see, when the base is same, if I have a to the power 3 by 2, then in that case, how did I get it as 3 by 2? 1 plus 1 by 2. Am I right? In that, I'm going to take a to the power 1 by 2, then a is left out. So that's the thing. So now here, let me just write x plus 4 whole to the power 1 by 2 I'm taking common. And what else is common? 2 is also common. I'm taking it out. Then I would be having 1 by 3 into x plus 4. And then minus, I would be having 4, then plus c. Okay. So now here, just we will go with the LCM thing. Then 2 into x plus 4 whole to the power 1 by 2. Then I would be having x plus 4 minus 12 divided by 3 plus c. Okay. So now here what we would be having here is 2 by 3 would be here, right? And this is nothing but root of x plus 4. And then I would be having x minus 8 plus c. That's the final answer. So whether I need to simplify till here, can't I stop it till here? You may be able to stop it till here if they didn't ask you to prove that, giving that, show that it is equal to, if they would have given this one, then you need to show this one. But professional way of doing, if you are willing, then I would ask you to simplify till the end. That's up to you. Either you can stop here or here. That's your choice. Now, next question. We would be considering this as I is equal to. So let's go ahead and check which one to substitute here. Obviously, the one which is preserved we would be considering. But the point is, when I go ahead and differentiate x cube minus 1, I get 3x square. But I have x power 5. So we need to do one simple thing, splitting and writing my x power 5. How will I do that? I would be writing it as x square into x cube. So I would be writing it as x cube into x square dx. Why did I do that? Just to benefit me, like how I would be able to solve to make my problem simpler, solvable one. So here, let x cube minus 1 be equal to t. In that case, I have, when I differentiate both the sides with respect to x, I would be getting 3x square dx is equal to dt. And then I would be having just x square dx. That means I would be substituting dt divided by 3. This is 1. And here, what is my x cube is equal to t plus 1. Okay. So we will be just going ahead and changing as per our substitution. So it becomes t to the power 1 by 3 and into t plus 1 into dt by 3. 1 by 3 is the constant. So I would be having t to the power 1 by 3 plus 1. So when we go ahead and I would be getting t to the power 4 by 3. So it is like t to the power 1 by 3 into t to the power 1. Base is same, the powers we would be adding. So 1 by 3 plus 1 is going to be 4 by 3. This is how we got it. Okay. So, and then plus t to the power 1 by 3 dt. Now let's just integrate it. I would be getting 1 by 3. T to the power 4 by 3 is, when I integrate, I would be getting 4 by 3 plus 1. It's going to be 7 by 3 divided by 7 by 3. And then plus 1 by 3 into t to the power 1 by 3. When I integrate, I would be getting t to the power 4 by 3 divided by 4 by 3 plus c. Now I would be having 3 gets cancelled, okay, and then so I would be having 1 by 7 t to the power 7 by 3. And then again here as well 3 and 3, because denominator when it comes to it becomes a numerator, it gets cancelled. I would be having 1 by 4 t to the power 4 by 3 plus c. Now what is t actually? T is nothing but the one which we substituted in the beginning, x cube minus 1, so whole to the power 7 by 3 plus 1 by 4 x cube minus 1 whole to the power 4 by 3 plus c. That's it. We're done with our integration. I'm not proceeding further here. Okay. And then let's move on with the third question. Okay. A very easy one here. Considering this as I equal to. Now, let which one should I go ahead and go for substitution so that I can get the other part of my question? Let me give a try with the one which is there in the bracket. 2 plus 3x cube, when I go ahead and consider it as t, and when I differentiate, I get 9x squared, okay, dx. So I have x squared dx in my question, so that works. So let 2 plus 3x cube be equal to t. Then when I differentiate both the sides with respect to x, both sides with respect to x, in that case I would be getting 9x squared is equal to dt divided by dx. So now let's go ahead and do the substitution here. We will change everything here. In that case, see this one I can also write it as 9x squared dx is equal to dt. So x squared dx is equal to dt by 9. So x squared dx is gonna be getting converted as dt by 9, and then this becomes t whole cube. That's it. So now 1 by 9 is a constant which I'm taking it out, and then I would be having dt divided by t cube. So t to the power minus 3 plus 1 divided by minus 3 plus 1. So we would be getting it as minus 2, which is equal to 1 by 9 when I integrate t to the power minus 2 divided by minus 2 plus c. So now here it becomes minus 1 by 18, and then t is nothing but 2 plus 3x cube whole to the power minus 2 plus c. Let me just write this in the denominator itself. So I would be getting 18 times of 2 plus 3x cube whole square plus c. That's it. Done. Okay. Now here let's move on with the fourth question. Now fourth question, when you observe, we have integrate 1 by x log x whole to the power m. What is the mention? X has to be greater than 0. When we are giving an input, say, logarithmic input has to be positive. It can't be negative. That's a thing which we have, but the output can be negative. We are speaking about the input. When I give, like when I substitute something, x value in here, when I'm giving an input for x, it has to be positive. That's the rule. Or else it becomes a complex number again. Just like your previous problem, that's the first problem. Just like that, even here also, to avoid that confusion, whether the complex number is taken into account or not. So we are making it very specific, stating that complex number is not included. Now let's start doing this particular problem. Okay, what you would be considering. See, when I consider x, when I differentiate, I get it as 1. And say 1 dx, that's not going to help me out in anything. Just dx is replacing by dt, but log x, it's not doing anything. I need something where I would be able to go ahead and integrate. So here what I would be considering is let log x be equal to t. Then I would be having 1 by x is equal to dt by dx when I differentiate both the sides with respect to x. Now here dx by x is equal to dt. Now let's go ahead and then substitute everything. I'm considering this as I. Don't forget to write that. That would be helpful when you practice it in the beginning itself. So here we have dx by x, that is dt divided by t to the power n. That's it. Now let's go ahead and integrate it. We have, we'll just write it as t to the power minus m dt. Now, how will we integrate this one? It is just a normal formula type. So in this case, when I integrate, I would be getting it as t to the power minus m plus 1 divided by minus m plus 1 plus c. So what is a t actually? It is nothing but log x, log x, okay, um, whole to the power minus m plus 1 divided by minus m plus 1 plus c. Now you would have understood why did they mention m is not equal to 1. See, here they have mentioned m is not equal to 1 because if m is equal to 1, what would happen? The denominator becomes 0, and if the denominator is 0, it is not defined. Just to avoid that confusion, that's the reason they are making it more specific. Okay. So here, if you want, you can also write it as a log x whole to the power 1 minus m divided by 1 minus m. Just not to keep the negative first, I'm writing it as interchanging and I'm writing it. That's it. Hope you understood till here. Now we will move on with the next one. So we have integral x divided by 9 minus 4x square. So now 9 minus 4x square when I differentiate something, I should get the other part of my question. That's what we do under substitution. So when I differentiate x and check, it's not helping me out. So I'm going with 9 minus 4x square. I'm considering it as one term and I'm differentiating it. If you want to take it apart, that's not going to help me out. Okay. Say 9 is left out and 9 minus t, again, it becomes a two term. I don't want two term in my denominator. I will consider the two term as one. That is 9 minus 4x square, I'm going to consider as t. So here I is equal to, so let's 9 minus 4x squared, if I consider as t, let me just differentiate both the sides with respect to x. I would be getting 9 becomes 0 when I differentiate, and minus 4x square becomes minus 8x is equal to dt by dx when I differentiate with respect to x. Okay. Now the question, see, my question has x dx. So what I would be doing, minus 8x dx is equal to dt. Then x dx is gonna be equal to minus dt divided by 8. That's it. Our problem is solved. Now let's go ahead and integrate. We would be getting minus dt divided by 8t. Done. So minus 1 by 8, I would be having integration of dt by t. Integration of dt by t, 1 by t is log mod t. So here minus 1 by 8, we would be having ln of mod t plus c. So which is minus 1 by 8 ln of, what is the t actually? 9 minus 4x square plus c. That's it. Simple, easy. Like you need to just understand which one to substitute. If you are doing, like just do it in the mind itself and have a check whether numerator or denominator. In denominator, whether both the terms or one term. If I'm taking one term, whether it is making it complicated, so instead I can take two terms. That's how it is. Because when you have a constant as another term, when you differentiate, it's gonna become zero. So consider both the terms. That would be helpful. Now let's proceed with the next one. So it is in a linear format. No need for me to go with the substitution. We have a formula for all this type, which we have discussed in the previous video. Whenever you're having your power as linear format here, in that case, we can apply directly. Now, whenever we integrate e to the power x, I would be getting it as e to the power x itself plus c. That's how we get it. So now here, what would happen is we would be doing directly, I would be getting 1 by 2 e to the power 2x plus 3 plus c. This is what my answer is going to be. If you are willing to do using substitution, I'm not going to stop you from that. What you would be considering is the one which is there here. See, something which is there, that one, 2x plus 3 is equal to t. So it's something which is preserved. Okay, something like e to the power raised to. The whole thing you consider as t. Then when I differentiate it, I would be getting 2 dx is equal to dt. Now, we have dx is equal to dt divided by 2. Now let's go ahead and substitute it. We would be getting 1 by 2 e to the power t dt. So now 1 by 2, when I integrate, I would be getting e to the power t plus c. 1 by 2, what is your t actually? It is nothing but 2x plus 3 plus c. So don't waste time doing all this. I would prefer you go ahead with this method. Already the formulas also has been given for this in the previous video. You can have a check pertaining to that. Now we will go with the next one, which is integrate x divided by e to the power x squared dx. If you would have guessed by now, and then your substitution is gonna be x squared. See, when whichever is coming in root inside, which is log of some, something inside. Okay, not log x alone, like log of some composition of another function or sine of the composition of another function. E to the power raised to another function. When you have something like this, those functions you consider for substitution and check the remaining part of the question. Whether when you differentiate these functions, whether are you getting the remaining part of the question. That's how you need to check. So when I do this, and I differentiate my x square, I get 2x dx. Though I'm not having 2, but I have x dx. That can be replaced. So that would work. So now here, 2x dx is going to be equal to dt. So now in this case, I would be having I is equal to dt divided by 2 e to the power t. Okay. So 1 by 2 integration of e to the power minus t dt, right? So integration of minus t or minus 2, integration of 2t is there, integration of e to the power 2t is there. I would be getting e to the power 2t divided by 2. The same way here also I have minus t means it is going to be e to the power minus t divided by minus 1. So here I would be getting minus 1 by 2 e to the power minus t plus c after integration. Okay. Now minus 1 by 2 e to the power minus of x squared. Okay. Plus c. This is what I'm getting. E to the power minus of x squared, I can write it as minus 1 by 2 e to the power x squared plus c. That's it. Very simple. Let's proceed with the next problem. So we have, okay, now the inverse functions are coming into our problems. So let's have a check with this one. See here, I have integrate e to the power tan inverse x divided by 1 plus x squared dx. Okay, so we have certain formulas under integration for tan inverse, sine inverse and all. When we are doing problem, I will explain about those formulas. Now, whenever you integrate, okay, not integrate, sorry, I need to differentiate. Whenever we differentiate instead of eraser, okay, just a minute. So, d by dx of tan inverse x, when we are differentiating, we would be getting 1 divided by 1 plus x square. Okay. Whenever, see these formulas, I would be giving it to you when I'm taking differentiation. Okay. For now, d by dx of tan inverse x, I would be using 1 divided by 1 plus x square is going to be the formula of differentiation. Now let's start. Now here, which one I need to consider? Let tan inverse x. See the one which is being preserved. I mean composition of a function, the inside function alone I'm taking. I'm considering it as t. Then 1 by 1 plus x square is equal to dt divided by dx when I differentiate with respect to x. And I have dx divided by 1 plus x square in my question, which is getting replaced by dt now. So see here, I is equal to e to the power t dt. That's it. Now, Let me go ahead and integrate. I would be getting e to the power t plus c. What is going to be t? T is nothing but e to the power tan inverse x plus c. That's it. Got over. So it's a very simple. The thing you need to know is differentiation. That's the only thing which you need to know. When you know differentiation, then it's easy. Okay, now come back to this particular problem. It's a quite interesting problem. Many times it's been asked in CBSE exams as well. These two problems, 9 and 10. Okay, and how to solve this? First, we have when we have e to the power 2x minus 1 divided by e to the power 2x plus 1. I need to bring it in a very similar format of the 10th question. Okay, so I will tell you the reason for this. First, what I'm gonna do, let me consider this as I is equal to. See here, when I substitute something, when I differentiate that, I should get the other part of the question. Here, when even in my numerator, if I go ahead and differentiate my numerator or the denominator, I'm not getting the other part of my question. So that means it's not working. In this case, what I would do is I would multiply. I need to make it like one, right? Where I can go for substitution, I can get the other part. So to make it in such a format, I'm going to multiply and divide by e to the power x. Okay. So when I multiply and divide by e to the power x, what would happen is, see here, I'm just considering the integrand alone now. E to the power 2x minus 1 into e to the power x divided by e to the power 2x plus 1 into e to the power x. Okay. Now, this e to the power x, which is there in the denominator, I'm writing it as e to the power 2x minus 1 divided by e to the power x. And this e to the power 2x plus 1, the one which is there here, it is nothing but denominator's denominator will become a numerator. I would have told that many times. I'm using that logic. Got it? So now here, what would happen is I would be getting, see the change of my integrand, how it is getting changed. It becomes e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. What exactly has happened? So see here, I have e to the power 2x divided by e to the power x, right? So when the base is same, when it is dividing, I would be writing 2x minus x, which is equal to e to the power x, right? So that's what I've written here. And then let me come back to them. You have 1 by e to the power x, which is nothing but e to the power minus x. That's what I have written here. Now that's how the numerator and denominator. Now see here, our integrand has been changed. Now, to such an extent it has been changed, you will observe something very special happening here. Now, let me consider my denominator as t. Okay. When we consider the denominator as t, when you differentiate your denominator, are you getting your numerator? That works. That is what we need actually under substitution. So, see here, I would be considering let e to the power x plus e to the power minus x be equal to t. Then when I differentiate, I would be getting e to the power x minus e to the power minus x is equal to dt by dx. I got the same thing. Now here, e to the power x minus e to the power minus x dx is going to be equal to dt. That's it. Now our problem is solved. I would be able to use the substitution method, which previously I was not able to, just to make it one. So whenever you have in this format of e raised to something, and if your neighborhood is not the of negative power of the same thing which is there previously, in that case you need to make one. So I think you would have got the idea about how to do that. Now after substitution, my problem is getting converted as dt by t, which is nothing but ln of mod t plus c. Right. After this, you're directly substituting ln of e to the power x plus e to the power minus x plus c. That's it. The problem got over. Now let's go ahead and do the next one, our 10th one. See here, it's already is in that format. So which one I would be considering? So I would be considering my denominator because the numerator, when I consider, okay, you are going to consider your numerator. Okay, when you consider e to the power 2x minus e to the power minus 2x. Um, so if you consider that as equal to t, then in that case, what you would be getting? When you differentiate, you would be getting 2 into e to the power 2x. And then minus is there, so minus of minus becomes plus e to the power minus 2x dx. Right? So even that works. Okay, whichever you find you want to do that, you can consider. Generally, like I consider denominator, but let's consider. See here. See here. I'm sorry. Just a minute. We had e to the power 2x minus e to the power minus 2x is equal to t. If we consider this, let's have a check whether it works. I think I did some mistake. Let's have a check. So it becomes plus 2 times e to the power minus 2x is equal to dt by dx. So 2, if I take common, I have e to the power 2x plus e to the power minus 2x equal to dt by dx. Okay. Now see here, we have that's in denominator. It's not possible. Okay, that's the reason we are considering. Okay, we are considering. Let me just. It's not working out. So that's the reason we are considering the denominator as t. So in that case, I would be getting 2 times e to the power 2x minus e to the power minus 2x. Okay, is equal to dt by dx. Okay, now you go ahead. I'm considering this as I is equal to. Then in that case, we have dt by 2. So dt by 2 into t. Now let's go ahead and then integrate it. We get ln of t plus c. 1 by 2 ln of t is e to the power 2x plus e to the power minus 2x plus c. I'm sorry for the mistake earlier. Kindly have a check. I think if I would have worked out, I would not have done a mistake. So let me have a check further. Okay, I'm sorry about it. Now let's proceed with the next one. We have tan square of 2x minus 3. So let's have a check with this particular problem. Which one we are going to substitute? Very simple, but tan square, do we have an integration? This is what we would be checking first. So in this case, we don't have integration for tan square. So we would be using a formula which under trigonometry, that is secant square x minus 1. So secant square of 2x minus 3 minus 1 dx. Now, we do have a formula for integration for secant square. So let's integrate directly. So we have integral secant square of 2x minus 3 dx and then minus dx. So secant square integration is gonna be tan, right? So but we have in linear format inside. That means 1 by 2 times tan of 2x minus 3 minus x plus c is gonna be my answer. Same way here as well, but I would be getting a negative sign when we are doing it because we have minus 4x. So let's start doing this one. I is equal to, I'm considering. I'm not going using substitution here, but I mean, I'm using the formula which has been derived using substitution method. So that you can use directly instead of wasting time. with the other procedures of considering 7 minus 4x as t and then doing it. Instead, we can use directly. So now here when I integrate, I would be getting secant square me when I integrate, I would be getting tan of 7 minus 4x. Then divided by minus 4, that is minus 1 by 4. I will just write like this. Plus c. That's it. That's it. Our integration gets over with this. So it's quite simple. So don't waste time using substitution. Use the formula which has been derived using substitution. Now here, okay. The inverse differentiation, if you know this problem becomes easier. We have d by dx of sine inverse x. Okay, the differentiation is going to be 1 divided by root of 1 minus x squared. Now, which one to consider t? By now you would have understood the sine inverse, I would be considering it as t. And then the remaining part is there in my question itself. So let me consider I is equal to. Now let sine inverse x be equal to t. Then 1 divided by root of 1 minus x square is equal to dx by dt when I differentiate it with respect to t. So now here, sorry, dt by dx when I differentiate with respect to x. I'm sorry. So here we have dx divided by root of 1 minus x square is equal to dt. Okay, so now let me go ahead and have a check with my problem, the one. So we have, so it becomes dt and then t. That's it. So now when you integrate t, it becomes t square by 2 plus c. What is your t actually? It is sine inverse of x the whole square divided by 2 plus c. That's it. It got over. Quite simple. Just you need to know the differentiation of sine inverse x. Okay, under substitution. And now here we have something, okay, like full of cos and sines. Let's have a check with this one. So here I have 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x dx. Okay, let me go with a substitution. But before going to substitution, whether I can take anything common from numerator? Not possible. Anything common from the denominator? Yes, I can take 2 common. So let's do that first. So I would be having 1 by 2, 2 times cos x minus 3 sin x divided by 3 cos x plus 2 sin x dx. Now, which one I need to consider as t, the numerator or the denominator? Okay, when you go ahead with the numerator, okay, that won't work because something is there in the denominator that should be gone. Okay, when I differentiate the numerator, I won't be getting like a denominator one. 1 by I won't be getting. So that's the reason it won't work. Let's have a check with the denominator itself. 3 cos x plus 2 sin x. Now, when you differentiate cos x, you get minus sin x. So minus 3 sin x you would be getting. And when you differentiate 2 sin x, you get 2 cos x. Whether you're having that as your numerator, yes, then that means our problem is solved now. We found out what we need to substitute. So now here, let's 3 cos x plus 2 sin x be equal to t. Then minus 3 sin x plus 2 cos x dx. I'm differentiating with respect to x. So dt by dx, so I'm bringing the other side. So now if you observe, that's nothing but your numerator. If you are still confused, I will just interchange and write it. You will be accepting whether it is equal to the numerator or not. Yes, now you would be saying, yes, it is equal. So now see here, my problem is getting changed as 1 by 2 dt by t. Now, what is the integration of 1 by t dt? It's going to be ln of mod t plus c. What is my t? T is nothing but 3 cos x plus 2 sin x plus c. That's it. Problem solved. Now let's move on with the last question which we have. Okay. So here we have 1 by cos square into 1 minus tan x the whole square. We have to integrate it. So I'm considering this as I is equal to, okay, which one to consider as t? See, when I consider something which is in bracket, let me give a preference for that. So if I consider 1 minus tan x, when I differentiate it, I get secant square x. Do I have secant square in my question? Obviously, I have 1 by cos square. 1 by cos square is nothing but secant square. So, to avoid the confusion, let's write in the beginning itself secant square x divided by 1 minus tan x, the whole square dx. Now, let 1 minus tan x be equal to t. Then in that case, minus secant square x, 1 when I differentiate becomes 0. So that's where I would be getting minus secant square x dx is equal to dt. So now let's go ahead with the substitution. I is equal to, I would be having um, minus dt because I have secant square x dx, but I don't have a negative, so I'm bringing it as minus dt by t square. So minus will come out, and then when I integrate t to the power minus 2, I would be getting t to the power minus 2 plus 1 divided by minus 2 plus 1. So t to the power minus 2 plus 1 is gonna be minus 1 divided by minus 1 plus c. This minus and this minus will go away, and I would be having 1 by t plus c. What is my t here? 1 by 1 minus tan x plus c. I think you would have understood all the 15 problems which we solved. One more, 10 more problems we will solve pertaining to substitution, and then I would also help you with different types of formulas like integrating tan x, integrating cot x, what we get a formula regarding those proof also we would be seeing. Thank you guys.